the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, Professor of Mathematics at Cosumnes River College in Sacramento, California. This video is yet another introductory video for those students who are taking linear algebra. You should have already watched my videos possibly on a review of linear equations and linear systems. All of this, I promise, is going somewhere. We're about to dip into kind of newer material. The topic we're going to talk about in this video, which is matrices, you might have already encountered in your pre-calculus course, or maybe a college algebra course, or even maybe an intermediate algebra course. A lot of students have been pre-exposed to this topic. So this is why I have this as a separate video, very quick review. Let's go ahead and just talk about it here. An introduction to matrices. The definition of a matrix. Well, a matrix, and the plural is matrices, is a rectangular array of numbers, symbols, or expressions arranged in rows and columns. To be honest with you, I always think of an Excel spreadsheet or a Google Sheet, if you will. That has actually made talking about matrices a lot easier now that everybody knows what a spreadsheet is. Some examples of matrices. First and foremost, I want to talk about the notation here. Notice I'm using square brackets. That's traditionally the type of container symbol that you use for matrices. However, there are some authors and some mathematicians who use parentheses. It's a bad habit, I think, but it doesn't really matter, honestly, in the long run. But it's a rectangular array, so we'll go ahead and we will list out some values here. Let's just say our array looks like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. You can see here this is a rectangular array. It happens to have 1, 2, 3 rows. So the rows are the data in the horizontal, rows. In the vertical, columns, those would be what we call columns. And the columns here are these blue columns. Of course, yellow and blue make green, so where they intersect, they're actually green. And so what I'll do here is I'll just note down below here that there are 4 columns. Now, I wasn't going to talk about it in this video, but I'll go ahead and talk about it right now anyway, because we're already talking about how many rows there are and how many columns there are, so we might as well just state it right here. This is what we would call a 3 by 4 matrix. And I usually denote it down in the lower right-hand corner of the matrix itself. It has 3 rows, so rows are listed first, and then 4 columns. Columns are listed second. And again, that's read as a 3 by 4 matrix. That's the size of the matrix. So that's an example of a 3 by 4 matrix. By the way, notationally as well, we generally reserve the capital bold letters for matrices, just like we reserve, for example, X or Y or Z for scalars, and technically we actually reserve Z for complex valued scalars, but whatever. We use capital letters to denote matrices. Generally, if you can make it bold, you'd like to, but that's hard to do with a pen or a pencil, to be honest with you. Let's go ahead and write down another one here just before I go into the actual definition of the size of a matrix. So let's go ahead and say, here's a matrix B, and we'll make up a matrix like this: 1, 0, -1, 5. Notice that matrix, and it is a matrix, has 4 rows and 1 column. So it's a 4 by 1 matrix. That is not actually the same as the matrix C, for an example, which I'll define to be 1, 0, -1, 5. Notice they contain the same numbers, but the matrix C does not have 4 rows. Instead, the matrix C has 1 row, and it has 1, 2, 3, 4 columns. So that's a 1 by 4 matrix versus the 4 by 1 matrix that B is. So there's a very strong distinction when you're talking about the size of a matrix, and it does make a difference that it's either what we call a column matrix, that's what this is right here, or a row matrix. Now, if you've taken, for example, Calc 3 or a few other kind of higher level math courses, you might call these vectors. And in some way, you're sort of right and you're sort of wrong. We will talk about that as we move forward, so don't make a big deal about it right now. Now, I've already talked about the size of a matrix, but here's the actual definition. The definition of a size of a matrix is as follows. The size of a matrix A that has m rows and n columns is written as m by n. We often say the matrix is m by n, so this matches up with what I was saying. M rows, n columns. A big warning here. We do not use the word dimension when referring to the size of a matrix. A lot of people love to say that matrix has dimensions 3 by 4 or something like that, but that's actually not correct. We reserve the word dimension for something else completely. So that is going to become important later on in this course. I have a bad habit, to be honest with you, of saying the dimension of this matrix is whatever by whatever. However, it is probably a good habit for me to start getting into just say the size of the matrix. The reason why we need the distinction is because as we move forward, the word dimension has to do with spaces. And spaces are very theoretical structures that we will be dealing with specifically in linear algebra. And so we need that word reserved and set off to the side for something else. So do not use the word dimension when referring to the size of a matrix. So let's go ahead and determine the size of this matrix right here. Very easy to do, right? You just count up the number of rows. We have 1, 2 rows. So this is a 2 by something. And let's count up the number of columns. 1, 2, 3, 4, and 5. So this is a 2 by 5 matrix. Very easy stuff here, but very critical that we get this stuff down. I say it a lot as you move forward through linear algebra. Definitions are critical in this course. It's very important that you have a solid background in understanding the language, so we're all speaking the same language, because as we move forward, things get really confusing, and holding on to core definitions, very important. The last one I'm going to go ahead and do here is this matrix here. And in fact, maybe I'll throw another one in there just because I want to. And one more because, again, I just really want to. All right, the matrix Z, well, that has 1 row and 1 column. So this is a 1 by 1 matrix, and that's okay. It's all right to have a matrix that's 1 by 1. Most people would probably call that a scalar. However, it is not a scalar, it is actually a matrix. And we will see later on why. It has something to do with multiplication. So this is a matrix, not a number. It is a collection of numbers. And it only is actually a collection of 1 number, but that's okay. The next matrix we see right here is full of zeros, and that's perfectly fine too. It doesn't all of a sudden compress down to a single element. It is just a matrix full of zeros. It has 2 rows and 2 columns. It's a 2 by 2 matrix. And finally, this guy right here, that is also a matrix with 2 rows and 2 columns. Very easy, very fast. This is a very special matrix. This is called the identity matrix, and it's the 2 by 2 identity matrix. And this one is very common because you can grow it to a 3 by 3 identity matrix, and that would look like 1, 0, 0, 0, 1, 0, 0, 0, 1. That's just kind of a neat little matrix used for a lot of different things in linear algebra. And you should note here that it has 1s along what we call the main diagonal and has 0s everywhere else. Again, I'm throwing out some language here that I'm not really writing out as definitions. I'm just quickly saying that these are the words we're going to use as we move forward. You don't need them yet. However, as we move forward in the course, we will end up defining that to be the main diagonal of a n by n matrix. Notice off the main diagonal, everything's zeros, and that's what makes this an identity matrix. You don't know why it's called an identity matrix yet, but I'm just telling you that's what it's called. It's not that big of a deal. Main thing here is to note that you now know how to find the size of a matrix. If I write down a bunch of matrices, you should be able to find their sizes. Okay, so in this video, we've just introduced the idea of a matrix and the idea of the size of a matrix. You should be used to the idea of a matrix because you've worked with Excel or you've worked with Google Sheets at some point. You have so many rows and so many columns, you have that data in there. That's really what a matrix is. It's a spreadsheet to hold data. The data does not always have to be purely numeric. In this case right here, we had variable data in there right here and right here. So it's just a heads up here that you can have variables within matrices. All right, I hope this video was helpful, or maybe you don't know it yet, but it will be helpful. So I hope to see you in a future video. Have a great day.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.